a really interesting thing. Around 75 years ago, they started doing this experiment, and it's quite strange. It's called the double slit experiment, and essentially it's very, very, very simple. You can fire particles at two slits. All right. This particle could be an electron, or it could be a group of an atom, or a group of atoms, like we were talking about before. Now, if you fire them one at a time through two slits like this, it creates a pattern on the other side of deconstructive interference and constructive interference. But you're firing them one at a time, one particle at a time. And this is very, very strange, the result, because the particle seems to interfere with itself over and over and over again as it goes to the other side, creating a wave-like effect of peaks and troughs, and peaks and troughs, and peaks and troughs, peaks and troughs, and peaks and troughs, and peaks and troughs, and peaks and troughs. This is really, really, really weird. And it's a particle. And this is when things got really, really strange in physics. And a lot of the time that this was being done, people would reject it because, well, how can one particle interfere with itself? Now you've got to realise that a wave of energy is a wave of possibilities. How can one particle know that it's going to be like all these other particles coming through, but none of it makes sense? We can all agree that doesn't really make sense. All right. Now what's really interesting is if you put a little reading device here and you observe, like a little eye here, if you observe which one of these goes through, you take a measurement of this electron and you observe which way it goes, the pattern disappears and it just turns into just a mess. All right, and that's what we would expect. If we're firing something through two gaps like this, it'll just be just a wave of particles hitting the other side. That's what we expect. So as soon as you observe the electron, it behaves like a particle. When you don't observe it, it behaves like a wave. So the wave of possibilities collapses into one particle when there's an observer. This has been repeated over and over and over again, and this is the basis of all quantum physics. So what we're going to talk about next is some of the ways that quantum physics shows that space and time don't really exist in the way we think they do. So there's a lot of information here, so we're just going to focus on this experiment, first one here. So you can entangle two electrons by shining light into a crystal called beta barium borate. And this makes two electrons that are entangled. They experience each other all the time. And people can do this with each other. We can entangle with each other and start to exchange information with each other. So one of the really strange things about electrons that are entangled is they exchange information over any distance instantly. And this kind of messes up our whole understanding of time and space, because it's faster than light. All right, so that the way they communicate is instantaneous. And this can happen between people, and physicists at the moment call this passion at a distance, because it's easier for people who are in love. It seems that the orientation of the heart entangles people. Two people can entangle together, and this has been tested with 1 hour of meditation. And this gets really cool. So you get two people and they meditate together with the intention of entangling, and then you separate them. You put one on the other side of the planet, and you hook one who's staying there up to an EEG. An EEG is an electroencephalograph, which basically reads the electricity on the skin. So the person who's on the other side of the planet, they're going to go and do stuff, and basically they log all their experiences when they might be under stress, or when they might get a fright, or when they're feeling good, or when they're feeling sad. The person who's entangled with them, who's being monitored on the other side of the planet, experiences those effects of what the other person's feeling in zero time. So the exchange is instant. It's faster than light. Okay, so you can do this especially with mothers and children and all these sorts of family things, or brothers and sisters. It's there's so much data there for this sort of exchange. So this is a normal human faculty to be able to tune into each other and feel what the other person's feeling, especially people that are close to us and more entangled with us, or people who share the same DNA. It's really easy for mothers because what's been shown recently is that stem cells from a baby travel back across the placenta and into the mother, and these are stem cells, and they will often actually go to her heart and become heart cells for her, but it's her baby's DNA. So if a mother has 3 children, she has stem cells from 3 different people in her body helping her out. But those stem cells are also entangled to the children, so this is why mothers have a lot more of a connection to the state and kind of health of her kids, no matter where they are. So yeah, interesting stuff. So we can entangle 2 electrons, and you can shoot them down a course, and there's a thing they've got called an interferometer. Okay, and this is a thing where an electron goes in and it has to choose a left or right passage out. So 2 entangled electrons, if one's got up spin, the other's got down spin, you can measure that as well. How's the electron spinning? They're always doing the opposite thing. So 2 entangled electrons, if you shoot them down a course and it goes to the interferometer, this one, let's say, takes the left passage. Its mate, its entangled friend, is always going to take the right passage if it takes the left passage the other way. Now, it doesn't matter the distance between these electrons. This could be 10 miles, this could be the other side of the universe. The distance doesn't matter. The information is exchanged, it's exchanged in 0 time. So we can see all these sorts of effects happening more and more of our life, but it's verified by these experiments which have been repeated over and over again. Now, it can get really, really interesting here. So if we get the same crystal of beta barium borate and we put the electrons in that makes an entangled pair, and we shoot them out one at a time, and we do the double slit experiment again. So if you measure one electron going out, it's just going to a measurement device. You're measuring anything about it. There's heaps of different ways they can do this. Its entangled twin, when it goes down towards the double slit experiment, it just creates a rabble. It doesn't create a wave-like effect, because measuring its twin means that this comes into a determined state. It's not a wave of possibilities anymore. You guys keeping up with me on this? Yeah? Alright, sweet. So you measure its twin, and it just creates no interference pattern. If you don't measure its twin, it will create an interference pattern and act like a wave again. It'll interfere with itself infinite times over. It'll just be a wave of energy, a wave of possibilities. And again, it's important to remember that when it becomes a wave, it is not a wave of particles, it's just a wave of energy. These actual physical particles turn into energy possibilities until they interfere, until they're observed, or its entangled twin is observed. Now here's where it gets even screwier. Let's just say this measurement device is 100 kilometers away, and these electrons travel at the speed of light. So, this experiment's close together. It's all close together. This electron's not going to be measured for 100 kilometers. This electron's going to, it's not going very far, it's just going, let's say it's going 30 centimeters, boom, boom, right there. So, if that's 30 centimeters, this one hasn't been measured yet. So of course it's going to act like a wave of possibilities and create an interference pattern, right? Because its twin isn't being, measured. Because it's still going for 100 kilometers. However, if at some point in the future its twin gets measured 100 kilometers away, this particle knows that its twin is going to be measured in the future, and it doesn't create an interference pattern. That means that the measurement in the future of this particle travels back in time and creates no interference pattern. So what does that mean about time? It means that time is a tool that we use to talk to each other so that we can plan shit. That's about it. Time and space are tools that we carry around with each other to try and make things make sense. These experiments show that information travels through space instantly. We can communicate with each other through vast spaces instantly. We can communicate with ourselves retroactively. If you had a bad time when you were 10, you can give yourself some good vibes right now when you're 10 and make it a bit better. This is where a lot of these healing kind of concepts come from, where we can actually alter our past retroactively. And this gets pretty, headache kind of material, guys, because, does that make sense? Right? Sweet. So these particles are communicating with each other backwards in time.